Hello everyone and welcome to another video of the hidden quantum champions. In today's video we are going to look at Quix quantum, and I don't want to talk too much for this introduction part, so let's jump right into it. On the website here of Quix quantum we see building the future of photonic quantum computing. So again, we are looking here at a company that is creating photonic quantum computers. As we saw before, it says Europe's market-leading company in photonic quantum computing. On the right side, we see some of the systems. Again, we see they are in this rack shape, which is a typical, let's say, size of units in server centers and telecommunication centers. So it's very much, let's say, put into a shape that is industry standard. And I guess they will also talk about like the fiber optics, the connectivity, the room temperature, and so on again. But let's see. So it says building Europe's photonic quantum computer. Quix Quantum is the European market leader for quantum computing hardware based on photonics. The company is building the first universal photonic quantum computer in Europe, with the first sale to the German Aerospace Center, DLR. The core technology behind our photonic quantum computers is award-winning and already commercially available. And then there's some more to learn here. There's a news section down here. I'm recording this end of August, so we see there's like, I think, no news here in August, but in July there was something new. Let's learn a little bit about their products. So it says our photonic quantum product, sorry. There's the universal quantum computer. So we see like the whole system here with I guess different units in there and that have different functionalities. Special purpose quantum computers. So I guess these can fulfill a specific task. And then there's the quantum photonic processor. And I guess we will learn more about these in a second. But let's go down a little further. Here it says discover our photonic quantum technology, photonic-based quantum computing. Let's quickly look into that. So Quix Quantum's photonics quantum computer uses particles of light, so photons. That's like the quantization of light, right? Like the smallest unit of light is a photon, as information carriers. It manipulates their quantum properties to encode computational problems for end users. The advantage of photonics as a quantum computing technology are room temperature operation, scalability, and a high degree of technology maturity due to the technology overlap with existing classical photonics applications. That is targeting to what we all know, like the fiber internet, fiber optics, and fiber optic based information transmission, right? Like all the high-speed internet of today is being transmitted, or like server centers, computing centers are talking to each other via these fiber connections, because you can transmit much higher information density than via like copper lines. And that led to extreme investments, or to high investments in that area. And of course, this technology is now available as a basis for this photonic based. Similar to what the spin qubit technology says about the CMOS technology, so the chip technology that is already in computers, which they are using as a basis for what they are developing. So our photonics quantum computer consists of three parts: sources, which generate the input quantum light; quantum photonic processor, which manipulates quantum light and where the computation takes place; and then finally the detectors, which read out the results of this computation. The core technology is based on our commercial available award-winning and target-leading photonics technology. This is used in our quantum photonic processors, positioning Quix Quantum as the leader among photonic quantum computing companies with our unique combination of lowest loss and largest scalability. So lowest loss probably as in like the loss of these single photons. So if you just operate on single light particles, they can, of course, they are like single quantum particles. So every interaction with the environment has a certain probability that they might do something which we don't want them to do. So imagine you have like two light particles, you want them to interfere with each other to encode some type of quantum gate, but now one is traveling through the fiber and there's like an impurity, I don't know, some atom in there, and then it interacts with this impurity, as in it gets absorbed, and then of course like the other light particle cannot interact, like these two light or this light particle in superposition cannot interact anymore because it gets absorbed by an impurity. The same is like for maybe reflections and other stuff. That's why you need like super high quality manufacturing here, and that's, I guess, what they are doing in order to reduce these losses. And then of course largest scalability probably refers to techniques they are using to scale. Here it looks like on this picture that they are using something like micro optical elements that you can produce like chips in order to scale stuff on a wafer, similar to computer chips, just with optics, right? Just as in with optics, it's not getting easier. Okay, then there's some information here about events where you can actually meet them. Okay, and then down here there's like a download for a data sheet. We also see they have different locations here. So there's Ulm in Germany, Amsterdam in the Netherlands, Stuttgart in Germany, and Enschede in the Netherlands as well. Let's quickly take a look at the products maybe first. So universal quantum computer. Our universal quantum computer is built to solve complex problems at the speed of light. Open bracket, probably at the speed of light in fibers, close bracket, and not vacuum, close bracket. But please, if I'm wrong here with that assumption, tell me down in the comments below. About the universal quantum computer, our universal quantum computer exploits the strength of award-winning quantum technology. I think we've seen that, and then we see here like the different industries they are targeting: healthcare, AI, logistics, high-tech, and finance. Okay, then we see that it's like a 100% pan-European supply chain, and we see some pictures of what the computer looks like. And then I guess the other products, these two, they are probably subcategories of that, as in like specialized subcomponents that will also be used for the computer. So here we see the special purpose photonic quantum computer. Our special purpose quantum computers are made to solve specific complex problems. About a special purpose quantum computer, our special purpose photonic quantum computer will help you solve specific problems in the optimization and simulation field at the speed of light. In the heart of photonic quantum computers, our quantum photonic processor. The system brings together the three essential components, and we've seen them before. So I guess where the first product is like a general computer where you can probably use a lot of gates and you can go in with arbitrary algorithmic tasks, like, I don't know, from optimization to chemical simulations. This one here is basically set up in a specific way, so there's not like an endless amount of connections between all of the qubits where you can tune everything in a way that you end up with the problem that you actually want to solve. But here it's really like optimized towards a specific type of problems, which means basically that these systems, I don't know, if you buy one for optimization, you can maybe not as easily use it for a different task. That's at least what I would guess when I look here at what it says in the text. Then there are also some documentations here, like I guess this document about the special purpose quantum computer. There's a white paper about silicon nitride building blocks, and then a white paper about the Quix quantum photonic processor. Silicon nitride building blocks, so I guess that's like also silicon technology. So maybe, yeah, chips, micro waveguides on there, and then optics, right? Finally, we have here the quantum photonic processor. About the quantum photonic processor, okay, Quix quantum's processor is a record low loss multi-mode reconfigurable interferometer. It allows the user to perform arbitrary controlled interference between a number of optical channels in a classical or quantum domain. A quick open bracket. So interference basically means that you have two different light beams, more or less, and light beams can also be single photons that you kind of split up. For example, if you have a semi-transparent mirror, you send a photon through, or a beam, then it basically gets split. Half of it gets reflected, the other half goes through. And now you can basically merge those again. So you take another pair of mirrors and you reflect them back so they go back into the same point, and then they interfere with each other. And now in the interferometer, what you can actually do is you can tune this interference. So you can maybe shift the distance that the one light ray versus the other light ray is traveling, and thereby you detune them a little bit. And hence you can create different types of interferences, as in like constructive or destructive interference. And here it says that they can be controlled, and that you also have a number of optical channels. So probably there's like multi-channel which you can actually input into this interferometer. And thereby you can perform certain types of operations, right? You can probably create superpositions when you split, and then when you merge again, you can also do like measurements, right? Here it says our photonic processors are industry leading in a number of optical channels, so up to 20, low loss, 2.9 dB, and high transformation fidelity, larger than 90%. The chip is turnkey, fully calibrated, temperature stable, and our dedicated control software allows seamless integration into your process. The maturity of the technology makes our quantum photonic chip an excellent solution for many applications, not only in quantum computing, but also for quantum communication, QRNG, machine learning, and more. The Photonic Quantum Processor won the Prism Award 2023 in the Quantum Tech category. Read more here. Okay, so quick note, we see here, so it's not only quantum computing, also quantum communication. I think we will look more into this when we talk about companies from the quantum communication space, but basically the idea here is that again you create particles that are entangled with each other. So they have a specific relationship with each other, and then you use this quantum entanglement in order to make sure that nobody is kind of eavesdropping on your communication channel. And that's kind of ensured by a principle called the non-cloning theorem. And for that, you actually need again this same type of technology that these photonic quantum computers are working with. You definitely need some of those components as well in order to create these quantum communication channels. So I guess that's also where they are like cross-selling here. Okay, with that, let's also check out the company, not the company, but the company quickly. Our company, Quix Quantum, is Europe's leading quantum computing company based on photonics, founded in Enschede, Netherlands in 2019, with office expansion to Amsterdam, Ulm, and Stuttgart in Germany in 2022. We are fabless, horizontally integrated company focusing on quantum computing using integrated photonics. So fabless means they don't fabricate those themselves, but they probably send those layouts, so they own the IP probably. They send the layout somewhere and then they get manufactured by some fab. This is nothing which is completely new. It's like something that already in the established silicon industries, big companies are doing. Like for example, NVIDIA, they are not making their own chips. They have the chips manufactured by a fab. NVIDIA is creating the IPs and the designs of those chips, and then they get manufactured elsewhere, which is a different approach than, I don't know, what Intel is still partially doing, where they actually have their own fabs and they produce those chips. Here then we see the leadership team. Then it says something about the investors here. So you see there's like a couple of big names in there as well. And then there's a get in touch field here. Also, there's something here about about the team and the investors. Okay, that's probably everything that we need to know here. One last thing, there's also a cloud computing part here, which kind of would get us to the cloud. Here it says Quantum Cloud will be back soon. So as I'm recording this right now, end of August, it doesn't seem to be up and running. With that, I think I will close today's video. I hope you liked it. If so, please give it a thumbs up. If you have some comments on today's video, let us know down in the comments below. And as always, make sure to stay hydrated. See you in the next one. Bye bye.